everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem: form partial differential equation from z equal to x into phi of y plus y into f of x by eliminating the arbitrary functions phi and f. So we are given a relation and we are asked to form a partial differential equation by eliminating this phi and f. Let's see. Given z equal to x into phi of y plus y into f of x. Consider as equation number 1. Now let's partially differentiate it with respect to x to find p. P is nothing but partial derivative of z with respect to x, right? So we'll partially differentiate it with respect to, we'll partially differentiate 1 with respect to x in order to find p. Partially differentiating 1 with respect to x. Dou z by dou x equal to partial derivative of x with respect to x is 1 into, this is constant, right? Plus y is constant. Partial derivative of f of x with respect to x is f dash of x. Since we have a notation dou z by dou x equal to p, so we'll just replace it by p. We'll get p equal to phi of y plus y into f dash of x. Consider as equation number 2. Now let's partially differentiate 1 with respect to y to find q. Q is nothing but dou z by dou y, right? Which is, in order to find q, we need to find partial derivative of z with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1 if you feel it's necessary. Since we are partially differentiating with respect to y, so we'll treat x as constant. Constant x into partial derivative of phi of y with respect to y is phi dash of y plus constant f of x into partial derivative of y with respect to y is 1. Since dou z by dou y equal to q, we'll get q equal to x into phi dash of y plus f of x. We got equation number 3. We got p and q. Now let's find r. R is nothing but partial derivative. Z square z, dou square z by dou x square. Just nothing but finding partial derivative of 2 with respect to x. Okay? Or this one. If you find partial derivative of this equation with respect to x, you will get r. Or partial derivative of p with respect to x is also r. See? P is nothing but dou z by dou x, right? Again, we can write this as dou square z by dou x square, which is r, right? R is nothing but partial derivative of p with respect to x. Okay. Partially differentiating equation number 2 with respect to x. What I'll get? Dou by dou x of p equal to dou by dou x of RHS of p. Okay. And also we know that partial derivative of p with respect to x is nothing but r, since it is dou square z by dou x square. Or you can write one more or two more steps here. Let me write it clearly. Dou z by dou x, which is nothing but dou square z by dou x square. Clear, right? Is equals to dou square z, since dou square z by dou x square equal to r. So just replace it by r. You'll get r equal to partial derivative. Here we are finding partial derivative with respect to x, so we'll treat y as constant. So partial derivative for constant with respect to x will be 0 plus, here y is constant, into partial derivative of f dash of x with respect to x is f double dash of x. This gives us r equal to y into f double dash of x. Consider as equation number 4. We got p, q and r, right? Next we'll find s and t. Now we need to find s, right? S is nothing but dou square z by dou x dou y. We can write this as dou by dou x of dou z by dou y, or dou by dou y of dou z by dou x. Since we know that dou z by dou y is nothing but q. In order to find s, you can find partial derivative of q with respect to x. Okay? Or this can be written as dou by dou y of dou z by dou x is p. In order to find s, you can also find partial derivative of p with respect to y. Either partial derivative of q with respect to x gives s, or partial derivative of p with respect to y gives. Okay, you can find any of these two to find s. Okay, I'll show one clearly, and the next one I'll just write it down and I'll show you. Okay, fine. Now I'll go for both are same. You can either take p or q. If you want to get s from p, you need to go for this. If you want to find s from q, you need to go for this. That's it. Okay, let me try for p. Partially differentiating to with respect to y. Okay, since dou square z by dou x square can be written as dou by dou y of dou z by dou x also. This is equals to dou by dou y of dou z by dou x. This one, RHS of, right? Or simply apply dou by dou y on both sides of equation 2. Right? Again, p is nothing but dou z by dou x, right? P is nothing but dou z by dou x. This gives us dou square z by dou x dou y. Sorry, it's dou z and dou x dou y. Okay, now it's clear. I'm so sorry. Right? Fine. This is equals to, this is nothing but s. S equal to, here we are partially differentiating with respect to y, so we'll treat x as constant. So we'll get partial derivative of phi of y is phi dash of y plus constant f dash of x into partial derivative of y with respect to y is 1. This gives us s equal to phi dash of y plus f dash of x. Consider as some equation number 5. Okay, fine. Now let's see another way. In order to find s, we can also pick this one, right? Partially differentiating 3 with respect to x, that is dou by dou x of q right? This is nothing but dou q by dou x. Dou q by dou x is again s, right? This gives us s equal to, here we are partially differentiating with respect to x, so we'll treat y as constant. You'll get constant into partial derivative of x with respect to x is 1 plus partial derivative of f of x is f dash of x, which gives us s equal to phi dash of y plus f dash of x, which is our equation 5. Okay, you can just go for this one or this one, it's up to you. Fine. Now we got s and we need to find t. Let's see. Now we need to find t's, right? T is nothing but dou square z by dou y square, which is nothing but dou by dou y of dou z by dou y, right? Again, dou z by dou y is nothing but q. So partial derivative of q with respect to y gives t. Now let's partially differentiate. Now partially differentiating 3 with respect to y. I'll just apply dou by dou y on both sides of 3. Since we are partially differentiating with respect to y, so we'll treat x as constant here, okay? Now, this gives us partial derivative of q with respect to y, which is nothing but t, or you can write it as dou by dou y of q is nothing but dou z by dou y, okay? Is equals to constant x into partial derivative of phi dash of y with respect to y is phi double dash of y plus partial derivative of a constant with respect to y is 0. This gives us dou square z by dou y square equal to x into phi double dash of y. Since dou square z by dou y square equal to t, this gives us t equal to x into phi double dash of y. We got, yeah, consider it as some equation number 6. T equal to x into phi double dash of y. Equation number 6. Now, with the help of 1, 2, 3, 4, 5, 6 equations, including z also, that is equation 1, we'll find partial differential equation with the help of all the 6. Let's see. We need to observe all these 6 equations to find the required partial differential equation. Let's see how we'll get it. Now, let's see the same patterns. In S, you have phi dash of y plus f dash of x. It looks like same pattern, right? 1 dash plus 1 dash. Fine. I think S will be useful here. And here in R, we have f double dash. In T, we have phi double dash. In P, we have phi plus f dash. And here, we have phi dash plus f. So, let's see. Okay. Here, observe, we have phi of y plus y into f dash of x. And here you're having x into phi dash of y plus f of x, right? Here you're having f dash and here you are having phi dash. In S, you're having phi dash of y plus f dash of x. So, if we multiply p with x and q with y, we'll get xy into f dash of x. And here, if we multiply this with y, we'll get xy into phi dash of x. If we can add these two by multiplying p with x and q with y, we'll get xy times of f dash plus phi dash, where phi dash plus f dash can be replaced by s. You are confused, right? I'll show you. Okay, in order to find partial differential equation, we have p, q and s, right? Sometimes we will just do px, qy and x. We'll multiply p with x, the equation of p with x and equation of q with y and equation of s with xs. This is what we'll do regularly, not regularly, in some cases, okay? Just remember this. P is nothing but equation with p, q is nothing but equation with q, s is nothing but equation s, right? Fine, now let's find ps, that is p multiplied with x equal to x times phi of y plus y into f dash of x, which gives us x into phi of y plus xy into f dash of x, right? Now let's find qy, that is q into y. Q, equation q multiplied with y. Y times RHS of q, that is x into phi dash of y plus f of x. This gives us xy into phi dash of y plus y into f of x, right? Consider as some equation number 7 and this as 8. Now let's add these two. Adding 7 and 8. We get Px plus Qy, that is LHS of 7 plus LHS of 8 plus RHS of 7 plus RHS of 8, which gives us x into phi of y plus xy into phi dash of x plus xy into phi dash of y plus y into f of x, right? Fine. Now let's take xy common from these two terms and let's write these two together. X into phi of y plus y into f of x. We have seen this somewhere, right? Which is in z equal to x into phi of y plus y into f of x. Let it be. Plus, now let's take xy common from these two equations. We'll get xy times f dash of x plus phi dash of y. Since we have z equal to, let it be x into phi of y plus y into f of x, and s equal to phi dash of y plus f dash of x. We can just replace the first two terms by z and this term by s. Okay, or we can rewrite it as px plus qy equal to x into, I'll just replace it now itself. I'll just replace it by z plus xy into, here I'll write this as phi dash of y plus f dash of x, so that it will be easy to say it is exactly s. Some will get confused if you see f dash first, right? So I can just replace it, rewrite it like this. Now this gives us px plus qy equal to z plus xy into, we know that phi dash of z plus f dash of x is s. We have replaced it by s, right? Px plus qy equal to z plus xys is the required partial differential equation, or you can just write this as px plus qy, just bring this z to LHS, you get minus z equal to sxy, or you can write this as sxy equal to px plus qy minus z, which is the required partial differential equation. Is the required partial differential equation. This completes the problem. Okay. Which comes from this or this. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.